All right, so here this says a function with two horizontal asymptotes. So this is an example of a function that, and it says show that it has different horizontal asymptotes to the left and the right. So I'm going to start with to the right. I did a little setup again, right? To the right means that x is getting really, 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 really big. Okay, so we're talking about the limit as x goes to infinity of 1 over 1 plus e to the negative x. Okay, all right, let's use some limit properties just to break this up for a second, right? So it is okay for me to take the limit as x goes to infinity of the top, because that's something I know, over the limit as x goes to infinity of the bottom, okay? And I might even go so far as to split up the bottom into two, okay? So if I do this, the limit as x goes to infinity of 1, that's the top, right? The limit as x goes to infinity of 1 plus, and if I rewrite that as 1 over e to the x, I think this will help us see what's going on. All right, so definitely for the top, we know that that's going to be 1 because it's constant. That's the y value of 1 and never leaves that. Same thing going on for that first part of the bottom there, but 1 over e to the x, as e gets really, really big, we know that e to the x gets really, really big. So 1 divided by something really, really big is 0, okay, which means then that this limit equals 0. So therefore, on the right, I'm going to have a horizontal asymptote at y equals 1, right? So this is the equation of the horizontal asymptote. Okay? Hopefully that makes sense to you. All right, now let's change it up. Let's look to the left, okay, which means what's going on with x? X is going to negative infinity if I'm going all the way to the left. All right, so let's start this again. All right, the limit as x goes to negative infinity of the function 1 over 1 plus e to the negative x. Sorry about the notification there. Okay, all right, same idea. Let's split it up on the top. Okay, and on the bottom, the limit as x goes to negative infinity of 1 plus e to the negative x. Okay. On the top, we know we're going to get 1. Okay. On the bottom, that first part's going to be 1. But now, let's look here, right? If this is the opposite of x, if I'm putting a negative number in for x, this says the opposite of that. So this is basically, e to the positive infinity, right? When I actually put in negative infinity to the negative x. So it's almost like you're saying the opposite of negative infinity, right, which would be positive infinity, so that's what's going on there. Well, e to the infinity, what happens to the very far right side of the e to the x graph? It just gets really, really big. And so this would be the same thing as 1 plus infinity, right, which is essentially 1 over infinity, which we know from earlier is 0. Okay, so that means on the left, there's a horizontal asymptote at y equals 0, which is different than what we saw on the right. Okay, so if you actually made this graph on your calculator, okay, here's what it would look like. And I'm going to try not to get too perfectionistic with my graph drawing here. Okay, so you would have this going on, okay, and on the left, it would be getting closer and closer to 0, and on the right, it would be getting closer and closer to 1. So if you actually graph this, it would look something kind of like this. Okay? And you can see that that's why it could have possibly two horizontal asymptotes.